The China space program is far more advanced than most people realize. According to Elon Musk, China's Heavenly Palace might currently be the most advanced space station ever launched by humanity. And he could be right. While it remains relatively under the radar in much of the Western world, China has been quietly and steadily expanding this remarkable orbital outpost. And just recently, they pulled off a breakthrough that could redefine the future of space exploration. So, how exactly did they do it? Back in 2011, the United States decided China wasn't welcome on the International Space Station. This restriction was enacted through a Department of Defense spending bill passed by Congress, which prohibited NASA from using its funds for any bilateral cooperation with China. The stated reason centered on national security concerns and human rights issues. But many suspect that the US could also be worried that China might swipe their ideas or do a little space-age spying. So, China said, fine, we'll build our own space station. Now, obviously, there's a lot more to the story of why China decided to build a space station, but we're not focusing on that right now. What's remarkable is that despite only about 2 decades separating the launch of the ISS and China's station, the technological difference looks like a leap of a century. China's space station Tiangong, which translates to Heavenly Palace, orbits Earth at an altitude between 340 and 450 kilometers, roughly the same range as the ISS. It was developed and launched by the China Manned Space Agency, CMSA, entirely independently. The core module Tianhe was launched on April 28, 2021. It was followed by 2 science modules, Wentian on July 24, 2022, and Mengtian on October 31, 2022. Unlike the ISS, a collaborative effort involving the US, Russia, Europe, Japan, and Canada, Tiangong was constructed by a single nation on an ambitious timeline. The addition of the Wentian and Mengtian modules significantly boosted the station's scientific capabilities. The Tianhe module, the core of China's space station, stretches 16.6 meters long and came equipped with a docking hub that can welcome both Shenzhou crewed spacecraft and Tianzhou cargo ships like it's hosting a high-tech orbital hotel. Helping with the heavy lifting is a large robotic arm, which was key in positioning the Wentian and Mengtian science modules. It also lends a mechanical hand during astronaut spacewalks. Compared to China's earlier test space labs, Tiangong 1 and Tiangong 2, Tianhe is a serious upgrade. It's not just bigger, it's almost 3 times heavier, weighing in at 22 metric tons. With the full Tiangong station and visiting spacecraft docked, Chinese astronauts now have a surprisingly spacious setup to work, live, and float around in. Tianhe is where the astronauts eat, sleep, and manage life in space. It even features regenerative life support systems. Yes, that includes a urine recycling system so crews can stay in orbit for extended missions without constantly needing resupply. On top of that, Tianhe also houses the propulsion systems that keep the whole station from gradually drifting earthward. In short, it's the beating heart of China's Heavenly Palace. So, yeah, China already has a pretty slick, fully functioning space station up there, but they're definitely not done yet. According to the China Academy of Space Technology, speaking at the 74th International Astronomical Congress, China has big plans to expand Tiangong in the coming years. Right now, with its 3-module setup, the station can support a crew of 3 for long-term missions, which is solid, but also pretty limiting when it comes to how much science and maintenance they can actually get done. Meanwhile, the demand for experiments is growing fast. And that means more space and more power are becoming critical. The plan is to expand the station to 6 modules, which would effectively double its internal volume. The first new piece on the blueprint is a multi-docking adapter with 6 ports, which will attach to the bottom of the current Tianhe core module. It'll be built to mirror how the existing 3 modules are arranged. So, instead of today's T-shaped layout, the station will evolve into more of a cross shape, or what some are already calling a double T. This expansion would allow China to send more space science experiment racks, support larger extravehicular experiments, and overall extend the scale of operations aboard Tiangong. Another major upgrade supporting China's space station and its broader space ambitions is the development of a reusable crewed spacecraft. Formerly known as the Next Generation Crewed Spacecraft, the Mengju spacecraft is modular in design, capable of carrying up to 7 astronauts, and comes in 2 versions, one for low Earth orbit missions like trips to Tiangong and another deep space variant designed specifically for lunar missions. The lunar version is a heavy hitter, weighing up to 26,000 kilograms, and is designed to carry 3 astronauts to lunar orbit. Once there, it will dock with a separately launched landing system for descent to the Moon. On June 17, 2025, the China Manned Space Agency carried out a zero-altitude abort test, also known as a pad abort test, using a Mengju test article at the Jiuquan Satellite Launch Center. The purpose of the test was to verify the spacecraft's crew safety systems in case something goes wrong during the initial stages of a Mengju CZ-10 launch. According to CMSA, the test was a complete success. Looking ahead, CMSA also plans to conduct an in-flight crew module escape test later in 2025, simulating an emergency situation during maximum dynamic pressure, one of the most intense moments of any rocket launch. As a relatively new addition to space infrastructure, the Chinese space station Tiangong is expected to remain operational for at least 10 to 15 years. This long-term commitment reflects China's strategic vision for sustained space exploration and development. Tiangong is set to play a pivotal role as a platform for scientific research and a launchpad for future missions, including potential ventures to the Moon and deeper into space. Meanwhile, aboard the International Space Station, new arrivals are being welcomed once again. NASA's Crew 11 mission successfully docked with the ISS at 2:26 a.m. Eastern Daylight Time on Saturday, just under 15 hours after launching atop a SpaceX Falcon 9 rocket from Florida's Space Coast. The crew traveled aboard the Crew Dragon capsule Endeavour, which has now completed its 6th mission, making it SpaceX's most flown crew capsule. The hatches between the 2 spacecraft are expected to open around 4:45 a.m. Eastern Daylight Time, with a welcome ceremony scheduled about an hour later. Notably, the docking occurred exactly 5 years after the return of Demo 2, SpaceX's first-ever crewed mission, which also used the Endeavour capsule to carry NASA astronauts Bob Behenken and Doug Hurley to the ISS for a historic 2-month stay. Crew 11 is led by NASA astronaut Zena Cardman on her first spaceflight. Her crewmates include NASA's Mike Fincke serving as pilot on his 4th mission, Kimiya Yui of the Japan Aerospace Exploration Agency on his 2nd flight, and Oleg Platonov of Roscosmos, also flying for the first time. Yui and Platonov are mission specialists. The Crew 11 astronauts are joining 7 current ISS occupants: JAXA's Takuya Onishi, commander of Expedition 73, NASA astronauts Anne McClain, Nicole Ornapu-Man, and Johnny Kim, and Russian cosmonauts Kirill Peskov, Sergei Rizikov, and Alexei Zubitsky. But honestly, we don't know how many more trips like this can happen. The International Space Station, ISS, has been a symbol of international cooperation for decades, hosting astronauts from NASA, Roscosmos, ESA, JAXA, CSA, and more. However, its end is drawing near. That's not exactly surprising. The ISS has far outlived its original lifespan. Think of it like an old car. When you bought it back in 1999, it was state-of-the-art. It served reliably, and it's still safe, but over time, it's gotten harder and more expensive to maintain. Spare parts are becoming scarce, and the upkeep is a growing challenge. The US alone, through NASA, spends around $3 billion annually to keep the station running. Continuous operation in low Earth orbit is no small feat. It requires a steady supply chain, constant maintenance, and the ability to respond to unexpected issues in one of the harshest environments imaginable. NASA and its international partners have agreed to extend the ISS program until at least 2030. This extension ensures continued scientific research for a few more years, but that's about it. By then, the ISS is expected to retire. So, does that mean China's Tiangong space station will be the only one left in orbit? Not quite. The 2030 extension also serves as a transition period. NASA is actively supporting the development of privately owned space stations. Companies like Axiom Space and Blue Origin are already working on building the next generation of space stations, with initial modules expected to launch within the next few years. The China space program is far more advanced than most people realize. According to Elon Musk, China's Heavenly Palace might currently be the most advanced space station ever launched by humanity. And he could be right. While it remains relatively under the radar in much of the Western world, China has been quietly and steadily expanding this remarkable orbital outpost. And just recently, they pulled off a breakthrough that could redefine the future of space exploration. So, how exactly did they do it? Back in 2011, the United States decided China wasn't welcome on the International Space Station. This restriction was enacted through a Department of Defense spending bill passed by Congress, which prohibited NASA from using its funds for any bilateral cooperation with China. The stated reason centered on national security concerns and human rights issues. But many suspect that the US could also be worried that China might swipe their ideas or do a little space-age spying. So, China said, fine, we'll build our own space station. Now, obviously, there's a lot more to the story of why China decided to build a space station, but we're not focusing on that right now. What's remarkable is that despite only about 2 decades separating the launch of the ISS and China's